Okay, so using okay, so you have to know the names. These are all sum and difference. These are all double angles because if you notice that the angle has been doubled with a 2.
Mm-hmm.
So sum and difference, so you just expand it like this. Sine 30, cosine 45, and then just mix it. Sine 45, cosine what?
40
30.
or
Yeah.
yeah,
Now
30.
I know the equation would have sine cosine.
Mhm.
I write it sometimes like sine cos. As long as you switch the 35 and the 45 between those two, that's fine.
Okay.
Okay, so what's sine 30?
Um, is it pi over 6?
No, no, pi over 6 is equivalent to 30, but sine of 30
Oh,
is there's a okay, did you memorize the chart that I told you to memorize?
um, no, I didn't.
No, I told you you have to memorize this. ADdeline, I'm telling you, I'm only giving you the good stuff,
I'm
okay?
sorry.
You have to do this or else you're not going to do well in class.
Okay.
Pi over 6, pi over 4, pi over 3, 1/2, rad 2 over 2, rad 3 over 2, rad 3 over 2, rad 2 over 2, 1/2, rad 3 over 3, 1, rad 3. Takes like 30 seconds to write it really fast. You want
Mhm.
to put this on the test on the back somewhere and always just reference it because your answer is literally here. Sine of 30 degrees is what?
1/2.
See? How? I mean, can't get any better than that. Okay, 1/2. What's cosine 45?
Um, is it
Here, copy the chart down. Copy it down.
rad 2 over 2?
Yes. All right, did you finish copying that?
Yeah, I took a picture of it.
Okay, rad 2 over 2. And then sine 45.
Sine 45 is rad 2 over 2.
Yep. And cosine 30?
Cosine 30 is rad 3 over 2.
Yes. Okay, so go ahead and multiply it out and simplify it as much as you can. So this would be rad 2 over 4, rad 6 over 4, and they have same denominator, so this would be rad um, um, rad 2 plus rad 6 all over 4, and this is your answer. Okay?
Okay.
It's not rad 8. You can't add the radicals inside.
Mhm.
All right, now angles are easy because you're just using numbers, but what about when you have radian measures like cosine 5 pi over 12? How would you find two radian measures that adds up to 5 pi over 12? Well, first of all, what are the radian measures that we can work with? Pi over
Um,
what? Pi 6, pi 4, pi 3? You get that?
mhm.
That's on
Yeah.
our handy dandy chart right there, right?
Yeah.
Anything with the denominator of 6, 4, and 3 will work. So, but how do you know what adds up to 5 pi over 12 with this combination? What can you do?
Um, make it the same denominator?
No. Okay, so what you want to do is just split the 5 pi into two numbers that add up to 5. Okay, so you have a few options. You have like 1 plus 4, or you have 2 plus what? 3.
2 plus 3?
But which one do we use? Well, you want to use the one that will help you cancel out the denominator on the bottom. You can't use pi over, you can't just use pi over 12. So I'm going to put 2 pi here, 2 pi over 12, and 3 pi over what?
3
12.
pi over
Okay,
12?
doesn't it make sense? These two
Yeah.
fractions add up to 5 pi over 12, right?
Yeah.
And then if you just simplify this will become pi over 6 plus pi over what?
Pi over 4.
See? Now you have a reference angle with 6 and 4 there. Okay, now you want to expand it. So cosine of pi over 6 plus pi over 4 will give you the answer for 5, cosine of 5 pi over 12. Okay, so what's our expansion pattern? Do you remember?
Um, I have it written down, but I have to memorize it.
I want to memorize it as you go right now, okay? So cos, sine, and you change the signs. So
Okay.
cos pi over 6 cos pi over 4 minus sine pi over 6 sine pi over what?
Pi over 4.
Okay. All right. Give me the value of each one. What's cosine pi over 6?
It would be rad 3 over 2.
Okay. What's cosine pi over 4?
Rad 2 over 2.
Yes. And what's sine pi over 6?
1/2.
1/2. And what's sine pi over 4?
Rad 2 over 2.
Okay. What do you get?
It would be rad 6 over 2. Oh yeah, rad 6 over 4, sorry.
4.
Then rad 2 over 4.
Minus rad 2 over 4. So they have same denominator, so you can combine it. It would be rad 6 minus rad 2 over 4.
4.
All right, you can do C by yourself later. Just find two numbers that either add up to 105 or see, what can we use for this one? How about like 120 minus, no, 135 minus 30? You can use that, okay?
Okay.
All right, and then this one is just recognizing that you can go reverse order. Do you see that? Do you see the pattern? Cos, cos, sine, sine. So this is a cosine sum and difference, and you remember the sign changes with cosine. So this is just basically cosine 15 minus what?
15 minus 60.
Yeah, which is cosine of negative 45.
40. Okay.
Got that? Yeah. The first number is what you put right here. Okay. And the second one that shows up, you put it right there. Okay, so what's cosine of negative 45? What quadrant are we in?
Is it quadrant 4?
We're in 4. Is cosine values positive or negative in quadrant 4?
Cosine values are positive.
Positive. Now, what's our value? What's the actual value at 45 degrees? Well, look at your chart. What does it say? Anything with cosine 45 is what? Chart that. Look at your photo, the picture that you took of the chart.
Alright, I'm blanking out right now.
I'm telling you, the chart's gonna save your life. Okay.
Okay.
So always use that chart. Don't use the unit circle. It's just too much. Anything with
Is
cosine
it
45 has what?
is it rad 2 over 2?
Yeah, and that's your answer.
Okay.
See how easy that was?
Yeah.
Yeah. The chart has all the values. You just have to figure out if it's positive or negative.
Okay.
Do you see the expansion for this one? This is a sine, right?
Yeah.
The question is it going to be 42 minus 12 or 42 plus 12?
Is it 42 minus 12?
Yeah, because the sine expansion follows the same, okay, the same sign. Here and here. All right, and you can do that. It's pretty easy. Sine 30, right?
Yeah.
All right, let's move on to this one. Do you know this one?
Isn't it just like trying to find one side or working with one side?
Yeah, I mean, wait, can you see the result of this? Like, this one's pretty...
Yeah, it would be turning the secant into 1 over cosine and then turning the cosine to, just keeping the cosine and crossing it out equals 1.
Yep. Then number 3. All right, do you know what to do here? Do you have an idea? Now remember, some of these, even though you don't know where to start, you can just start somewhere and you just kind of go as you just keep going, and you'll eventually get to the other side if you don't make a mistake. This one you can actually start on both sides, but I would actually start on what side?
The left?
Okay, but do you have a reason why?
No, I don't.
Okay, so this is how I would reason it. On both sides there's cosines, right?
Yeah.
But the left side has a sine, so I know what to do with the sine. I can replace the sine with something that will produce a cosine. Does that make sense?
Yeah.
So the right side gives me a clue. There's no cosine at the end. I mean, there's no sine value at the end, right? So on the left side, I have to substitute this out with something else. What can I substitute sine with?
Is it 1 minus cosine squared?
Yes. So it's going to be 1 minus cosine squared alpha. That's exactly right. And then you just start simplifying. Try it. You distribute the negative.
Okay. Um, okay, that makes sense.
All right. So how about this one? You're looking at both sides. They look equally complex. How is secant and tangent related? Is there like a formula where both of them are related?
Isn't it 1 plus tangent squared x equals secant squared x?
There you go. All right. So which side do you want to? Okay, do you know what to do? Do you have an idea?
Replacing. I could work on the right side and then replace the tan with the secant. Oh wait, would I still be able to do that because
Well,
there's a
you have to move this one to the other one.
the other side?
Yeah, so that if you want to replace just the tan, you have to set the equation equal to tangent squared x. You get that?
Yeah.
So yeah, in place of tangent, you can put secant squared x minus 1 right here.
Okay.
So try it. It'll work. 1 minus secant squared x minus 1. And do you see it?
Yeah.
So we got 2 minus secant squared x. And there you go. And the same thing will happen if you replace the secant squared x with the tangent. And then do your, simplifying and you'll get the other side.
Okay.
I'm going to skip number 5. I don't know if she made a typo but you should ask Mrs. Town for 5. Do you have class tomorrow?
No, I had it today.
When's your test on this one?
My test is Wednesday.
Next Wednesday? Okay, so make sure you ask for number 5. I'm gonna still work on it, but I feel like there's some typo there where it doesn't actually work out. Okay?
Okay.
Do you remember her mentioning number 5 at all in class?
No, I don't think she did.
Okay. Yeah, I'll send it to you if I find it. I tried it with Stephanie and it just got long and complicated, and I was thinking maybe there's a typo with the 2. Anyways.
Okay.
All right, so here, what do you, okay, when you see this, what do you see? Just a bunch of mumbo jumbo. When I see this, I see fractions. Do you see a bunch of fractions?
Yeah.
And do you see like more fractions right here? This is 1 over cosine.
Yeah.
And this is 1 over cosine right here, right?
Mm-hmm.
Yeah. Now, obviously, the left side is more complicated, but basically, a fraction got reduced to another what?
Another fraction?
Yeah. So you're basically trying to get on the right side 1 over cosine of y, and then turn that back into a what?
Secant?
A secant. Okay. So you're like, where do I start? Well, do what you can do, like in terms of like substituting. Take the secant y, turn that into 1 over what?
Cosine y?
Yeah. Okay. And then from here, it's literally just algebra 1. We're going to get common denominator of the top, combine these two fractions right here. And then eventually, you're going to have to take the denominator, which is like that, and then what?
Flip it?
Flip it, yeah, and multiply it to the numerator. Okay, so let's work on the numerator. Their common denominator is cosine of y. So we'll write cosine of y, and to do equivalent fractions, you have to have an extra cosine of y over here. All right, does that make sense?
Mm-hmm.
And then the bottom will be just, 1 minus cosine of y. And then combine the top, so that'll be cosine of y, 1 minus cosine of y, over 1 minus cosine of y, over 1. And then basically take that and you what? Flip it, and you should see where it cancels out, right?
Yeah.
Oh, right, cancel. And look, we got 1 over cosine of y as predicted, and that becomes secant of what?
Secant y?
Yeah. All right, any question on that one? Easy?
No.
Yeah, fast because there's a lot here, and trying to pile it all in. Okay, so where would you start? Now, do you notice that this right here is a double angle? Do you see that?
Yeah.
So you have to recognize that immediately and then figure out what it becomes. If you did expand it, sine 2x will become what? Look at your notes. What would you expand sine? How would you expand sine 2x?
It would be 2 sine x cosine x.
Yeah, 2 sine x and cosine of x. Okay. Now I'm obviously going to start. Okay, the reason I did that is because that's going to tell me that as I work on the left side, I'm looking for a 2 sine x cosine of x, and then I'll convert that back into what?
Sine
Sine
2x.
2x. If you didn't see that, you're just kind of going circles. Okay.
Mhm.
So you just kind of do a little work on the right to give you a hint, and then obviously you usually, okay, about 95% of times, start on the side with the bigger exponent, which is this side right here.
Mhm.
And you ask, well, what can I do? Well, do what it's telling you to do. Take the whole thing and do what?
Multiply. Oh, wait,
Where?
no. X1 by 2.
Well, see, this one you have to do like this. Okay, you can't give the power to each one separately. You have to multiply the whole thing out.
Mhm.
Okay, now algebra 1, this is FOIL. This times this times what? That.
That.
You want to distribute it. So this will be sine squared x plus sine x cosine of x plus sine x cosine of x and plus cosine squared x. Okay. Now, do you notice something where these two are the same right here, right?
Yeah.
So this will become what?
Sine squared. Oh.
No, they're being added. Yeah, the 2
Okay.
sine x. And you now recognize something about this one and this one.
It equals 1.
Yes, it equals 1. And guess what? Doesn't that look like what we had up here?
Mm-hmm.
So now you realize, oh, now think about it. If you didn't know your double angle formula, you get stuck. You didn't realize that, wait, this is a sine of what? Double angle 2x. Okay, you see that?
Oh, yeah.
So yeah, you'll probably just stop here and go, am I doing something wrong? Because you're supposed to get what?
The
That.
sine.
Yeah, but if you know your double angle, you'll say, okay, I'm on the right track. Do you see how that works?
Yeah.
Yeah, so you have to know those inside and out.
Okay.
Yeah, bunch of fractions, okay?
Mm-hmm.
The right side is a fraction. It's basically 2 over what?
Uh,
Cosine of theta,
2c.
right?
Yeah.
So I just do that just to kind of show me like, or put in my mind, on the left side, I have two fractions with a bunch of different denominators. Eventually, I want something with cosine as a denominator, okay?
Mm-hmm.
And there's one right there, but this one is different. So again, it's just pure algebra 1. Get common denominator and just keep going and see what happens, basically. So what's our
Okay.
common denominator here?
Cosine theta times 1 plus sine theta.
Theta, th. Theta is actually this. You know that? That's the
Oh.
ph sound, the f sound. And
Mm-hmm.
then this is the th sound, okay?
Oh, my bad.
Theta. All right, so cosine theta times 1 plus sine theta. And 1 plus sine theta. Okay, so common denominator and equivalent fractions, you need to multiply the one that's missing to the top. And cosine theta times an extra cosine what? Theta?
Theta?
Okay, try it. Work it out and see where you go. Or something like that. Did you multiply out the left side as 1 plus 2 sine theta plus sine squared theta?
Yeah.
Okay. So 1 plus 2 sine theta plus sine squared theta plus cosine squared theta. Okay. What do you notice? There's
I noticed the sine squared theta and the cosine squared theta, which equals 1, I'm pretty sure.
So you're going to have 2 plus 2 sine theta. Now, do you notice that I'm not multiplying the denominator out, right?
Yeah.
Okay, so for the most part, usually, okay, you want to always leave the denominator in its multiplication form, the factored form.
Mhm.
The numerator always multiply everything out and try to combine. And eventually, there should be something you can like cancel. Like, do you see right here that you can cancel eventually if you do something? Like, in your head, factor out a 2 from both of these. What would it become?
Oh, 1 plus sine theta.
Do you see that?
Yeah.
Yeah. So that's how you kind of do these. You have to kind of see what might happen if that happened. Okay, so cancel, cancel, and you get 2 over what?
Cosine theta.
Yeah, which is exactly what we were hoping for, right? See this?
Yeah.
And it becomes 2 secant theta. Yeah. Now this one, if he allows you to use the co-function identity, it's literally one line. This is literally just cosine of x.
Okay.
If you knew the theorem, and you're supposed to, now I think you should put in here to see if you can actually derive it using the sum and difference. So do you notice that this is a difference right here?
Yeah.
Okay, do you remember the pattern for sine? Okay, cosine was cos, sine, sine. Do you remember the pattern for sine expansion?
Is it sine, cosine, minus sine, cosine?
Yeah, and you just switch these two inside there, right?
Mhm.
All right, do it. So sine pi over 2 cosine of x. Oh, and by the way, even though there's a negative here, the minus, you don't put the negative in here. Got it?
Yeah.
Yeah, so don't make that mistake. The minus goes over here, right there. So in the minus, and then just flip it. So sine x cosine of what? Pi over 2.
2.
Okay. Do you remember what sine pi over 2 is?
Is it 0, comma, wait, no, it's 1.
So this is just cosine of x. And what's cosine of pi over 2?
Is it 0?
0. And 0 times anything is what?
0.
0. So it's just cosine of
X.
x. Okay. All right. Pretty easy.
Yeah.
Okay. Then this one. Okay, I wouldn't be surprised if she put this next one as like a bonus. Okay, this one's gonna be long. You're gonna have to write a lot. Okay, so where do I even start? Okay, now they're assuming that you know your tangent expansion. Right, look at your worksheet and look at your tangent expansion, and you'll see the exact same formula on both sides. Do you see it?
I don't see a tangent expansion formula.
No?
No, I don't think Miss Town gave us one.
Okay. So if you take a look at the one I put up here, see this?
Mhm.
It looks exactly like the one you have there, right?
Yeah.
So this is actually equal to that and vice versa. But the real question is, can you derive it on your own? So you have to do this using all of what? This stuff. Okay?
Whoa.
So I'll show you. It's actually pretty easy, but it's just a lot of writing. But it's an identity. Okay, I don't know why she didn't give it to you, but you're supposed to recognize that this is simply just what? That. But remember, like we like this one right here, right? This is an identity, but we have to prove it.
Mhm.
So here we go. Now you might be asking, like, where do I start? Well, it's a little bit tricky, but we're gonna start on the right side. But before we do that, we're gonna start on the left and just kind of break it down a little bit and realize that tangent of x plus y is no different than writing it this way. Sine of x plus what?
X plus Y.
Yeah, over cosine of
X
x
plus
plus
Y.
y. Yeah. Now again, our goal is to get here, but the reason I broke this down is so that as I'm working on the right side, I can visually see where I'm headed, and you'll see why I did this. Because in order to work with this, you have to split up all the tangents into sine over what? Cosine.
Okay.
Okay? Yeah. Because I mean, there's nothing we can do right now, right? There's just there. So
Mm-hmm.
as you're working with this, if you don't write this out, like as you're going down, you will know like where you're after. Okay?
Mm-hmm.
So tangent is always sine over what? Cosine?
Cosine.
No matter what's inside here. So watch this. We're gonna take every tangent and just open it up to sine x, cosine of x, plus sine y over cosine of what?
Cosine
Y.
Y.
hmm And 1 minus sine x cosine of x times sine y over cosine of y. Okay, now you see a bunch of fractions, right?
Yeah.
So for the most part, all like identities will have some form of a fraction where all you have to do is basically get the common what? Denominator.
Denominator.
And you're hoping to see this and what? This, but in its expanded form. So watch this. So let's work on the top. Let's get common denominator and really, really make sure that you don't miss the x and the y's. You have to distinguish the x and the y's. So this is going to become cosine of x, cosine of y, cosine of x, cosine of y. And for the numerator for this one, this will become sine x, cosine y, and then sine y, cosine of what?
Cosine X.
Yeah. Now, do you already see the expansion? Sine, cos, sine, cos. Do you see that? Isn't that
Yeah.
going to eventually become sine x plus y?
Yeah.
Okay, so there you go. And then on the bottom, well, this one is a 1, so we have to get common denominator for that one too. And the denominator again is cosine of x, cosine of y, cosine of x, cosine of y. And for the equivalent fraction to become a 1, obviously it's going to be the same thing. In the top right here will stay the same, sine of x, sine of y. And do you notice at the bottom one? Cos, cos, sine, sine. Isn't that a cosine expansion?
Yeah.
There we go. So, okay, you see what I'm getting at? It's going to become these two, right?
Yeah.
Yeah, except there's this big old denominator that we got to figure out. Well, it's going to eventually cancel out. Okay, now anytime you have separate fractions, always combine it. So this would be, let's use a different color, cosine of x, cosine of y, and the numerator will be sine x cosine of y plus sine y cosine of x. And then on the bottom, sine of x cosine of y minus sine of x sine of what?
Y.
Y. Okay, so far we have what? How many lines? 1, 2, 3, but it's like a lot of work here. Okay, so we have one fraction on top, one fraction on the bottom. Take the denominator and what? Flip it and multiply it, and you'll notice that the cosine x, cosine y will cancel out, right?
Yeah.
So I'm not going to write it out. I'll just assume that you kind of see that and just write this. Sine y cosine of x all over cosine of x cosine of y minus sine of x sine of y. And you'll say, oh, I recognize the expansion. The numerator is basically sine of x plus what?
X plus y.
And the denominator, cosine, remember, it's always opposite signage, right? So this
Yeah.
would be cosine of x plus y. And anytime you have sine over cosine, you can rewrite it as tangent. And voila, we are done. You see it?
Yeah.
Okay. Yeah, you could review the video later, but it makes sense, right?
Yeah.
Okie dokie. Here we go. So what time is it? All right, we're making good time. Okay, there's 25 questions. All right, solve the equation in the interval 0 to 2 pi. Okay, so remember, a lot of the stuff here is just basic algebra 1. Like if you were to solve for something like 2x squared plus x, anytime you have like a quadratic situation, you factor it and set it equal to what?
0.
0. Yeah, do you see how this works? Like this?
Yeah.
So it's literally the same concept. So except it's written with like these cosine stuff. So you write cosine x parenthesis 2 cosine of x plus 1 equals 0. See that?
Yes.
Yeah, okay. And then you just set each factor equal to 0. This is cosine of x equals 0. This is 2 cosine of x plus 1 equals 0. And then now you have two equations to solve. Okay, so here is a situation where you have to ask, where on the unit circle will you get a cosine value of 0?
It would be at
There's two
wait,
places.
when they ask that, is it like asking for the points?
Yeah, okay.
Like
Do you see it
pi?
where it says like 0 to 2 pi?
Mhm.
So we're going to stay within one 360 revolution.
Okay.
They're asking for angles.
Oh,
They're asking for
okay.
angles, but if they write it as 0 to 2 pi in this in the prompt, you have to give it as a radian measure. So if you
Okay.
submit an angle, you'll actually get it marked wrong. So
Okay.
what angle does cosine what angle does the radius have to be where the cosine value is an x coordinate, correct?
Yeah.
When is the x coordinate 0 on the unit circle?
Um, when it's at the point 0, comma 1 and 0, comma negative 1. So wait.
No. Okay, 0 comma 1 is when the radius is raised to 90 degrees. Do you get that?
Okay.
All right, do you see what's going on here?
Yeah.
The 0 here, that's your x coordinate.
Okay.
So when you're like this right here, this is 0 comma 1, right?
Yeah.
This right here is your cosine at pi over 2 equals what? 0.
0.
And where else is it 0? 0 negative what?
3
1?
pi
And what?
2.
Yeah, exactly. So when x is equal to 3 pi over 2, you also get a cosine coordinate, an x coordinate of 0.
Okay.
Okay, is that clarifying?
Yeah.
Okay, so let's try this one. Again, now that you have like a simplified version, you want to set it equal to cosine um, and figure out what it's equal to. So cosine of x is equal to negative 1/2, right?
Mhm.
Now, anytime I do this, always draw this t-chart, okay? Because usually you're gonna have to look at two quadrants for all trig functions. Which quadrant is cosine negative?
Cosine is negative in quadrants 2 and 3.
Yeah, so I write 2 and 3 like this, okay?
Okay.
Yeah, so I strongly suggest, okay? If you do this, your teacher's gonna be really excited because you're organizing your material. So in quadrant 2, what angle? Oh, let's do this. Look at your chart. Remember the chart that I told you to write down?
Yeah.
Look at your chart and look for the digit, the value 1/2 under the cosine column. What angle does it refer to?
Pi over 3.
Yes. Okay. So that's now pi over 3 is your first quadrant. How would you represent pi over 3 in the second quadrant?
Um,
Wait, does that statement make sense, what I just said?
can you repeat it? Sorry.
Sure. Okay, so look, in your first quadrant right here, pi over 3 will be like 60 degrees, right?
Yeah.
Yeah, pi over 3 or 60 degrees. So what would it be in your second quadrant if the reference angle is still right over here? If that's going to be 60 what?
60 degrees?
Meaning, this is how you're supposed to look at it. When you do this, your x coordinates is going to be the same, but your angle will be different. You have to go all the way over what?
All the way around?
Yeah, but be shy of 60 degrees. Does that make sense?
Yeah.
This is your reference angle. This is your what? Reference angle. In quadrant 1, we call it 60 degrees, but in quadrant 2, we have to call it 100 and what?
120?
120. Wait, does that make sense?
Yeah.
Okay, but so what's 120 in radian measure though?
Is it 2 pi over 3?
Exactly, 2 pi over 3. So x equals 2 pi over 3. Now, what is it in quadrant 3?
Um,
So that means you have to go in another 60 degrees this way, right?
yeah.
And what would that be? Okay, degree-wise, what would that be?
Degree wise?
Meaning, if you're at 180 and you went in another what?
Oh, 60 degrees?
So what would this angle be? Like if you go from here to here, is that?
Yeah.
Just add 60 plus 180, which is what?
Is it no, sorry, 240.
240. But what's the radian measure for 240? Do you know?
I
Do you
don't
remember?
have it memorized.
Okay, I told you, don't rely on the unit circle. Watch. Pi over 3 is like 1/3, right?
Yeah.
So 1/3, 2/3, 3/3, and what?
Oh, 4/3.
Wait, do you remember me showing you that a long time ago?
Yeah, I just got confused. I was gonna say like 3/3, but I knew that wouldn't be right.
Yeah, well, 3/3 is right here. Got it?
Yeah.
Yeah, so oh, by the way, like, okay, let me just review. Any denominator for radian measures, it just means cut the upper part into three equal, like, segments. Three equal, like, pies, I guess. Three equal slices of pizza, okay?
Mhm.
And so pi over 3, 2 pi over 3, and what? 3
3
pi
pi
over
over
3?
3?
You just cut the bottom one into three more pieces. 4 pi over 3, 5
5
pi over 3, and then what?
6 pi over 3, which is 2 pi.
Which is 2 pi. So if you had something like, where's like 7 pi over 6, right?
Mhm.
Well, the 6 tells us cut the top into how many pieces?
6.
6. So 1, 2, 3, 4, 5, 6. And then an extra, this right here will be 7 pi over what?
7 pi over
Yeah.
6.
So 6 pi over 6 is pi right there. Okay.
Okay.
Uh, okay, so x is equal to 4 pi over what?
Over
3.
3.
Okay. All right, number 12. All right, so notice, what do you call this guy right here?
Theta.
No, like the 2 times theta situation.
Oh,
Double what?
double angle.
Yeah, because the angle's being doubled. Make sense?
Yeah.
So you have to like look at your chart, or you have to memorize it and expand it. Now there's you'll notice in your chart, the one that your teacher gave you, does it have 3 equations next to cosine 2u?
Yes.
So you can use any 3. And now the question is, which one should you use? Now, you should memorize all 3, okay? And don't get the -1 and 1 minus mixed up here. Got it?
Okay, yeah.
So the question is, which one should you use? Well, if you go back, there's a sign on the other what?
On the other side?
Yeah, you want to have one trig function with just one type of like trig function. So if you, okay, first of all, you always want to set it equal to 0. So this will look like this. Cosine of 2 theta minus sine theta equals what? 0? So you're
Okay.
thinking, I want to turn this guy into a sine only, right?
Yeah.
So which one of those three would you use?
Um.
The 1 minus 2 sine theta, right?
Yeah.
Yeah. So guess what? When you do that, everything becomes just a sine equation. Does that make sense?
Yeah.
All right, and then just start simplifying. Oh wait, sorry. This is 1 minus 2 sine squared theta. Okay.
Okay.
Now, anytime one of them is a squared and the other one's not, you got to do like factoring, like you know those X method type of stuff.
Mm-hmm.
So you rewrite it as 2 sine squared theta minus sine theta plus 1. And because it's equal to 0, you can multiply through by -1 and turn this into a positive. So 2 sine squared theta plus sine theta minus 1. And now you have to do your factoring. Now, do you remember how to factor with X method? This is
I
no
just
different.
turn it
Huh?
like
You just
back
plug,
into
yeah,
um.
like
Yeah.
just,
Yeah.
okay, what would you put right here then?
I would put. Is it 2 sine?
Yeah, 2 sine theta. And this right here has to be what?
Just sine
Yeah,
theta.
because this is 2 sine squared theta, right?
Yeah.
Okay, and then what about on the other two empty spots?
Um.
You have to kind of play around with it until you multiply into a -1 and add to a 1 sine theta, right?
Yeah.
So,
Um. Would it be? Would it just be 1 minus 1,
wait, 1 minus 1?
or
Okay, what would you
um
put right here? A +1 or a -1?
I like to rewrite it as like 2y squared plus or 2x squared plus x minus 1 because it like I
Okay,
can visualize it better.
yeah, that's fine. 2x squared plus x minus 1, all right? And this is 2x and x, right?
Yeah.
Okay, keep going.
Um
Okay, so if you're stuck, resort to your x method. Do you remember how to do this?
oh wait, is it -2 and 1?
-2 and +1?
Yeah.
Well, no, because -2 times 1 will be -2, but we need a negative what?
Oh, sorry, it's been a long time since I've done this.
Yeah. So see. I don't want to give you the answer because you actually have to do this in order to finish the problem. So do you remember how to use the X method?
Can you remind me how to do it
Okay.
again?
So um, okay, I'll give you both. So the way I do it is okay. These two will always multiply into the first term.
Mm-hmm.
The last two will always multiply into the last one.
The last term?
Yeah. Now the middle one right here, it's the outside numbers multiplied plus the inside numbers multiplied. Okay.
Okay.
So what you do is you like this 2x and x. You figure out that times that equals that. Check.
Mm-hmm.
The outside numbers to multiply into -1, you only have one option. 1 times -1, right?
Yeah.
So you just play with the number. You make one positive, one what? Negative,
That
and
one.
then you test it out. If you go outside, you'll get -2x, right?
Yeah.
Inside, you'll get positive x, but then -2x plus x will produce a negative x instead of positive what?
Positive
X.
x.
And you're like, okay, let me just switch the sign, right?
Yeah.
Like that. So -1 times +1 will still equal negative what?
Negative
Negative
one.
1. Outside is positive 2x, inside is negative x. Combine it, you'll get positive what?
Positive x.
Yeah. So now you can just you know, rewrite that as 2 sine theta minus 1, sine theta plus what? 1.
This one.
Now, not all of these are going to be as easy as that. So if you get stuck, here's the X method. You just basically take the first number and the last number and you multiply it. 2 times -1 is negative what?
Negative
2.
two.
And then you put the middle term, which is a 1, and put it on the bottom. and you have to figure out two numbers that multiply into -2, while the two same numbers will add up to +1. So 2 times negative what?
-1.
Yeah, so 2 times -1 is -2. 2 plus -1 is +1, right?
Yeah.
And then these two replaces the middle term x. So you'll write this as 2x squared plus 2x minus x minus 1. Okay, do you see how this was
Yeah.
originally 2x plus x minus 1, but they just kind of broke the x into two separate numbers?
Yeah.
And then you do the factoring by grouping. You look at the first two and say, oh, okay, 2x goes into x plus 1. And the second one, you factor out a -1, and this will become x plus 1. There's like an invisible 1 right there. These two are exactly the same. Then this will become 2x minus 1, x plus 1. Okay, you should bring back some memories, right?
Yeah.
Fond memories. Okay. Obviously, it takes longer than just jumping in and doing this. So you can use this, but you just have to know what to look for. The first
Okay.
two goes to the first number. The last two multiplies into the last number. So you want to go in that order. Check the first number first, last number second, and then check the middle guy at the very what? At the very end.
Okay.
Multiplying the outside two and adding it to the multiplication of the inside two.
Okay.
Okay. All right. So now we're not even done, right? We have to like set this equal to 0. Okay. So this will become what? 2 sine theta minus 1 equals 0. Sine theta plus 1 equals 0. And this will become 2 sine theta equals 1. Sine theta equals -1. And sine theta equals 1/2. Sine theta equals -1. Okay, again, always do your little t-chart because you're most likely going to have two quadrants to look at, right?
Yeah.
So sine theta, all right, when is it positive? What quadrants do we look at?
It would be quadrants 1 and 2.
Yep, and look at your chart. What angle produces a sine value of 1/2?
It would be is it 30?
Well, remember, 30 is the degrees, but we want the radian measure.
Oh, is it pi over 6?
Yes, pi over 6. What is it in quadrant 2? Remember, quadrant 2, you need to use the equivalent radian or angle, reference angle. So if you went all the way to quadrant 2, what would it be?
Um,
Try to do that fraction thing I told you.
I'm stuck if it's 2 pi over 6 or 3 pi over 6.
Look, so this is 1 pi over 6 right here, right?
Yeah.
It's got to be the same height on the other side. That means it's got to be like this. Does that make sense?
Yeah.
So this right here is pi over 6. So there's 6 portions. You have to go 1, 2, 3, 4, 5, 6, right?
Okay.
So it'll be 1 less than 6 over 6, which is what?
5 pi over 6.
5 pi over 6. Okay, does that help?
Yeah.
Okay, so much easier if you kind of get used to that.
Okay.
Okay, and then what? Now here, there's only one place where the sine value is -1. Do you remember what that was?
Is it 3 pi over 2?
Yes, this one is just theta equals 3 pi over what? 2.
Over 2.
Okay. All right. Now, 5 minutes. I'm going to do one in the second section.
Okay.
Okay. Now, sorry, the second section. All right. So notice the instruction. It just says solve the what?
Solve the equation.
Okay. Now, this is different than this, where it says solve the equation in the interval. See that?
Mhm.
When they say in the interval from 0 to pi, you have to give the actual angles. This one, this one, this one, and what? That one. If they don't state the interval from 0 to 2 pi, you have to give a general answer that gives you all possible answers. You have to do that 2 pi n thing. Do you remember that?
Yeah.
So yeah, you're not going to give an actual answer. You're going to give like a equation that produces all the what? All the answers. Now,
Okay.
do you notice that this is basically the one we worked with, the quadratic stuff?
Yeah.
Okay, so watch. I'm going to do this fast because time's running out. So this is 2 sine of x. That multiplies into 2 sine squared x. Outside
Hmm.
over here, obviously it has to be a 1 and a what? 1, but the question is, well, which one is positive, negative? Well, the middle guy is negative 1. That gives it away. So 2 times the outside number is negative, well, it has to be negative 2 plus 1, right?
Hmm.
So 2 times that negative 1. So this will be plus, this will be what? I'm sorry, this will be negative, this will be positive.
Okay.
And just test it out. Positive 1 times negative 1 is negative 1. The outside 2 is negative 2. The inside 2 is positive 1. Negative 2 plus 1 is negative 1. Okay? All right. So how do we write your answer? Well, you set it equal to 0. 2 sine of x plus 1 equals 0. And this is sine of x equals negative 1. Sine of x equals negative 1 half. And sine is negative in 2 quadrants. Quadrants 3 and quadrants what?
Quadrant
4.
4.
The reference angle is pi over 6, right, from the chart?
Hmm.
Yeah. So, but you have to go all the way to the third quadrant. So it'll be like 1 pi 6, no, pi 6, 2 pi 6, 3 pi 6, 4, 5, 6, and then quadrant 0 will be 7. Do you see that?
Hmm.
So this would be x equals 7 pi over 6. But if you add 2 pi n, you go right back to 7 pi over 6. So you have to say 2 pi what?
2 pi n.
Now, does Miss Town use k or n?
She uses n.
Yeah. Okay. And then in quadrant 4, what do you think it is? 7 pi, 8 pi, 12 pi over 2 will go all the way. So you just go one less. It'll be 11 pi over what?
11 pi over 6 plus 2
Plus
pi
2
n.
pi n. Yeah. So these are your answers.
Okay.
Okay. So always remember that. When they ask you for just solve the solution and no interval, then you have to give an equation as your answer.
Okay.
Okay. All right. Oh man, I was hoping to finish all this. So, well, you're gonna have to work it out. I'll try to send a video with the last few. Um,
Hmm.
but yeah, just try it on your own and just
Okay.
review this video. All right, I'll
Okay.
upload it later. Okay, see you later.
Thank you.
Bye.
Bye.